because that brings me to another interesting thing that we can just chat a bit about on, I think, which is right into the detail, because you've actually built some computer vision stuff, and I think it'd be interesting for folks to hear actually, well, how do you do that? So could you just describe, just tell the story you told me of what you had to do? And you literally started from nothing, albeit being able to code yourself and being familiar with that sort of world, but never having done it before. What did you do? What was the scenario that you found yourself having to do it?
Yeah. So, and I'll briefly give some context on it. It was the context on it is we wanted a robot as a start to be able to read a gauge, right? And I had proposals from the team to do this, and what I couldn't understand is the one with the budget was, is that a good deal, right? Is it a good deal for the numbers you're telling me, right? And through questions that came up, I said, look, put in a very fundamental way or simple way is, can I go hire some kid from the local high school to do this in a weekend? Or is it going to take a team of data scientists 2 years to do, right? And didn't really get the answers that I was looking for that made me feel comfortable to spend this amount of money to do something that we didn't know how easy or hard it was. And so what we did instead is we created a little challenge within the team and said, all right, well, I'll tell you what, let's try and do this ourselves and see how easy or hard it is. And that was both, the approach I thought was as a good steward of BP's money here, right? But also, I've always wanted to learn Python, and I wanted to learn computer vision, right? I used to program. I'm fluent in 3 different languages, if you will, all programming languages, but I wanted to get Python. So, I learned Python and kind of went online through GitHub, just local, or publicly available or models, if you will, and built a model in about a week and a half, 2 weeks, that could read pressure gauges, right? And now I took a different approach than our data scientists. They took a pure machine learning approach, right? Where I don't tell it anything. I'm just going to, basically, mark up all these pictures and then teach the model. I took more of a logic approach in regards to, well, a gauge is typically, right, not all of them, but it's typically going to be round. And so let me look for circles and pictures, and let me zoom into that picture. And a needle is typically going to have a line or be a line, and that line is not going to be, more than the size of that gauge, and it's not going to be less than whatever number I gave it through trial and error. I think it was about 25%. And use basically existing, I would say, algorithms within the computer vision software, if you will, or models that were out there. I think it was like how circles and how lines is what I used, and basically cobbled those together to be able to identify the gauge, identify the needle, and then I found some OCR models and said, well, shoot, if I can understand all the characters on here, let me do that, right? And so then I pulled all those in, I sorted them and filtered them for numbers, found the 2 biggest numbers and what spread that had, and then I knew basically the grading of that entire gauge. I knew where the 0 point was, I knew where my needle was, and now it's just simple, is it trigonometry or, sines, cosines to get from this quadrant to that quadrant and blah, blah, blah.
Yeah, that's trigonometry.
But it was pretty quick, right? Yeah. And so what I found is it demystified it for me, right? It demystified the computer vision. And it gave me an opinion, which may not be the right opinion. I'm by no means a 10-year expert in this space, but it gave me the opinion that the likely answer is probably a combination of machine learning and a combination of logic, right? It's very similar to what we talked about a couple of weeks ago on digital twin, right? I mean, within a couple weeks, I was able to create a model that could read a gauge, and it took about a second to come through, which isn't good enough, right, for computer vision that needs to hit every 16th of a frame. But do I really need that here? Probably not. And so it's and the value I could get from it right away, pretty quick, right, by using logic and some of the existing stuff out there. I don't need to build something brand new, right?
I think that's a terrific example. And actually, that's how even stuff like self-driving cars happen. That the whole thing isn't done by AI. What you're doing is you're using these sort of trained AI libraries and you talked about how circles. So that's a well-proven library that's great at detecting circles. And it's a small enough defined problem that it's got millions of ways to do it. And it's been proven. So you can use it in your program language, just like a call. You just make a return count circles or something, and then you can return an array of all the circles in an image and work through them and start doing stuff. So you're using the AI to do the latest stuff, I guess, but you're stringing it together then in a sequential or a typical program way. Then it's just you're able to do more than you were before, and you're building in all your knowledge of the fact that I'm looking at pressure gauges here. I don't need to worry about differentiating stuff, although that raises an interesting question. To then deploy that, the robot first needs to find the pressure gauge to look at. I guess you've got a second layer of the challenge then in orienting it. But to solve this particular thing, you've already narrowed it down using your own know-how to say, well, we've only got certain types of gauges. They're either round or square. They've either digital or needles. So I just need to solve these two.
No, absolutely. And I think, look, I think this whole technology discussion that, many are having, I think it all boils down to that. I think it's, look, I'm a subroutine type of guy, right? I'm a modular type of guy. And I mean, when I was building, software programs, that was kind of the way I approached it. I want to make a solid subroutine here. And once I do that, it's done, right? I put it to the side, and it is either I turn it into a library, a DLL, and I only call it now because I know it will never fail. And if I have errors in my code or there's something wrong, I know it's not that, and to help focus. And I think that's the approach that I took, and I think that's the approach to, if we want to capture value soon, quicker, and keep pace. I think that's the approach that needs to be taken. I think it's not about creating the next best Lego piece. It's about how you're putting existing Lego pieces together to build that structure that you want to build, right? I used to build spaceships back when I was a kid with Legos. We didn't have all the cool pieces they have today that have been made to, and they wouldn't rival the spaceships that my son builds. But you knew they were a spaceship, and they did the job for me. And it took that long to get new Lego pieces built. You could do it with the existing technologies today. We don't have to create a whole lot new. It's about finding the platform to be able to put all of these Lego pieces on. It's that green board, right? That's what you need.